my name is Genevieve Robert, and I was one of the C++ programmers for this project. My colleague and I developed the lead resistor value calculator system, which serves as the backbone for the program by accepting the user's inputs, validating them, and ensuring that the calculations are performed accurately. My role was to write part of the code that accepts the important inputs such as the lead name, the supply voltage, the forward voltage, the lead current milliamps, the lead current amps, the resistor value, the resistor power. I also use the lead circuit class to keep all the lead circuit information organized, including the resistor value and power rating, making the program easier to manage and maintain. Finally, I use conditional statements to validate the user's inputs and ensure that only suitable values are processed by the program. Thank you.
My name is Kumi Kelvin, and I was also part of the C++ programmers for this project. My responsibility was to also help develop the lead resistor value calculating using the C++, and I also converted the algorithm and pseudocode into the working C++ program by using concepts such as the variables, the input, the output, also the sign, the if statement for input validation, the loops for repeated calculations. The program also uses the Ohm's law to be able to calculate the correct resistor value for the lead circuit. After that, I was able to run the program, the code, and I tested it to ensure the calculations were accurate. Finally, I was able to upload it to the GitHub repository. Thank you, sir.
My name is Jobu Edward Orlando Yao, and then I'm a member of Group 3.4 of the C++ MISM project. I am the one handling the GitHub operations, all the works that needs to be pushed to the GitHub repository. I am the one handling all.
So this is the GitHub repo. We have all our works pushed to this site. B208, the course code, and then the lead resistor value calculator system, which is the name of the repository link. So we have here everything in our repository. We have the flowchart in a Word document form, the project algorithm, we have the pseudocode as well, the readme markdown file, the C++ program itself, and then the screenshots from the various works that we have done.
Hello guys, my name is Madison Nathaniel, and the role I played in the project was to design the flowchart. So basically when we see, these are flowcharts. The heading is lead resistor value calculator system. So we begin by input lead information, number of lead name, supply voltage, lead forward voltage, lead current in milliamperes. Then we go on, are all inputs valid? If they are, display valid. If they are not, displays error. Then from there we come and calculate the current, the resistor value, the power rating, and from there, if the current is more than 30 milliamps, it will display warning current is too much. If it's not, it's going to display design accepted. Then from there, it's going to display all results. If there are more circuits to be processed, it is going to process them. If they are not, it will save it into a text file. So that's all for the flowchart. Thank you.
Hello everyone, my name is Janet Owusuwa Apia, a member of Group 3.4, and I was the algorithm writer for the lead resistor value calculator system. In this video, I will be explaining the concept of algorithm and reasons why we write algorithm before coding. Yes, so then see, our algorithm consists of the following steps. You have to start the program, which marks as the beginning of the program. You display the program title, which is the name. You ask the user to enter the number of lead circuits. Then you continue with the procedure to the end. Thank you.
Please, my name is Samuel Buakunochi. I'm in Group 3.4. My job was to produce the
pseudocode. I explained the logic gate, the logic behind the coding we did. So I started by displaying the title, the program, and then accept all user input. Then I check whether the input is valid or not. So for short, I made it understandable by the individual person. Yes, I just translated the coding to the normal person's understanding.
My name is Anita Akate, a member of Group 3.4. I am the testing lead. The testing is about so I have my red lead over here. So I entered the lead name. So it came the lead name. So I entered the name of the lead, which is red, and then the supply voltage 5, the lead forward voltage, which is 2, and then the desired lead current, which is 20. The result is design accepted. So the design accepted this input or these values because the supply voltage is greater than the lead voltage. The current is within the safe operating range. Therefore, the program accepts the design. Now to the blue lead. So we have our supply voltage to be 3 and then 3 volts. The lead forward voltage to be 3.2 volts, and then the desired lead current to be 20 volts. So the result is invalid input values. Calculation cannot continue. This is because the supply voltage is less than the lead forward voltage. Hence, the calculation cannot continue. Thank you.
I'm Richmond Edu. I'm in group 3.4. I'm doing the presentation.
So this is the presentation.